Hey guys, Mr. McKinney here, just going over average and instantaneous rates of change. So to get started, let's think about a secant line. So let's go all the way back to geometry. If you have a circle, a secant line is a line that cuts through and touches that circle at 2 points. That's a secant. A tangent line is one that just barely touches. So there's a tangent line. We're going to be starting with a secant line when we talk about the average rate of change. So if we think about a curve that looks something like this, if I want to know the average rate of change between these 2 points, let's call this one x1 and y1, and this one x2 and y2, then if I want to find the average rate of change, all I need to do is find the slope of this line that goes through these 2 points. And if we think back to Algebra 1, the equation for slope is y2 minus y1 over x2 minus x1. So whenever you see a question that's asking for the average rate of change, rate of change, you're going to be using a slope calculation, and you're just going to take the 2 endpoints of whatever time frame they give you. So again, average rate of change is the slope of the secant line. Wherever you're taking notes, put this one in real big writing, because this is a really important one. Anytime it's asked for the average rate of change, just find the slope. And it is important that you show the slope calculation, and I'll talk about that in a second. So, the distance an object falls in feet after t seconds can be modeled by y equals 16t squared. So let's think about what this graph would look like, because I want to know the average rate of change from 1 to 3 seconds. This object is falling. So let's draw a graph of 16t squared. It would look something like this. Because when you drop an object, it goes straight. Wait a minute, something went wrong there. Oh, this is telling me as time increases, this y is the distance that it's fallen. So even though the y value is going up, that's telling me how much it's fallen. Okay, so I want to know the average rate of change. When I see the word average, I know it has to be a slope calculation. So I'm just going to be doing y2 minus y1 over x2 minus x1 from 1 to 3 seconds. So I find it helpful to make a table off to the side where you do your x and your y. So when x is 1 and when x is 3. So when x is 1, I'm going to plug it in, 16 times 1 squared. Then when x is 3, 16 times 3 squared. Now, if you're on the non-calculator portion, you don't have to type this, you don't have to figure this out. You can just leave it like this when you plug it into your calculation, into your slope formula. So I'll demonstrate what I mean. y2 minus y1, I would do 16 times 3 squared minus 16 times 1 squared over x2 minus x1, 3 minus 1. On the AP exam, I can stop here if I'm on the non-calculator portion. But if there's a multiple choice portion, you may have to multiply it out. It depends on whether we're taking the exam in person this year or if it's virtual again. So let's practice working it out. 16 times 1 squared is 16. 16 times 3 squared, 16 times 9 would be 144. So up here I'd get 144 minus 16 over 2. Now let's say that you work this out off to the side and skip this step. If you just jump straight to here on the AP exam, if you don't show any of these other steps and go straight here, you're going to lose credit, because the AP exam needs to see where this 2 comes from. And it came from 3 minus 1. And yes, you can do that in your head, but you need to show that. Show So get in the habit of showing the setup of your problems. Let's go a little bit further. 144 minus 16 would be 128 divided by 2, which would be 64. And I forgot up here I'm going to need a unit since it's in feet and per second. My unit here would be feet per second, or 64 feet per second. All right. So for average rate of change, all you need to do is figure out the slope of a secant line. All right, when we want to talk about instantaneous rate of change, it's going to get a little bit more difficult, and I'm going to save that one for the next video.